Hi grade 9s, congratulations on making it through Unit 6. Today we're going to do the Unit 6 practice exam, and I'm going to go through and show you how I answer these and the thought process behind it. One thing I do want to mention though is there are some extra word problem practice questions, and I also put the answers up on the in the Unit 6 section or the Module 6 section, and it should be listed above this practice exam. Now those aren't required and they're not for hand-in, but I would recommend that you go through them and make sure you understand how to set up your word problems using the 5 steps and how to complete them and make sure that you are getting the same answers that I'm getting, because there are definitely a few on the exam. Okay, so this exam, we're going to have both equations and equalities. You're going to do lots of solving for variables in grade 10, 11, and 12, so we want to make sure that we're good at it. If you start out with fractions, you should end with fractions. If you start with decimals, you should end with decimals. Now, we have lots of practice on these from Unit 5 and Unit 6, and a little bit in Unit 4 as well. So I'm going to go through them reasonably quickly, but as always, if you're struggling with a concept or you can't figure out what I did or why I did it, please send me an email, and then we'll make sure that you understand for the unit exam. So solve each of the following equations or inequalities. I just added the inequalities part, so that might not be on your sheet, but the questions should all be right. So we always want to isolate for the variables. We want to keep the variable on one side positive and get all the numbers or the constants to the other side. So I'm just going to keep the t there for now, and I'm going to add 10 to both sides. So that's going to be 58. Now it says show your work, but I mean for a question like that, really all you have to do is show the top part there. You don't have to write out 5 different lines or anything. This one's decimals, so I can end in decimals. I've got a positive 2.5, so I'm going to subtract 2.5 from both sides, and that is going to leave me with 41.2 on this one, I believe. Number 3, now we've got 6a, so we've got a coefficient in front of the variable, and it's a negative coefficient. We always want to have, if we're solving for a, we need to solve for a, not for negative 6a, so negative 6a is multiplication, so we do the inverse, which is division, to get rid of that negative 6. So negative 6 divided by negative 6 just cancels to 1, which means we're left with a on one side, and then 54 divided by negative 6 should be negative 9 on the other. And then on question 4, we've got the opposite. Instead of multiplication, we've got division. So x over 2, any fraction is division, and because it's division, we can reverse it by using multiplication. So we're going to multiply both sides by 2. So we've got a 2 up top and a 2 on the bottom. That was the whole point of that, was to cancel it, get rid of the fraction. And we're just left with the x, which equals 10 times 2 is 20. Now we've got our first inequality. So make sure you keep your eyes peeled for inequalities on the exam. There are going to be both equal signs as well as the inequality sign. So just make sure you double check and make and ensure you're using the proper sign for the question. The solving for the variables is very similar. A similar process, but remember, if you're dividing or multiplying by a negative number, you have to flip the sign, so that'll have an impact on your answer. 2y minus 4, let's just keep the 2y there for a second. We'll add 4 to both sides, so that is currently 2y is less than 28. Then we got to divide by 2, and because we're dividing by a positive number, the sign stays the same, so we're left with y equals 28 divided by 2 is 14. Over here, now we've got the y on the other side, so remember that's going to have an impact on us as well. So we've got 6 equals 3y minus 24. Let's add the 24 to both sides to get the numbers on one side and the variables on the other. Now because, well, we can do the math first here. Let's, this is equals, so we don't have to worry about flipping any signs on this one, I guess. We need the y alone, so we're going to divide by 3, and what we end up with 10 equals y. And remember, when it's an equal sign, when it's an equation, you can just flip it around without having to worry about anything else. Now we've got another inequality. This time we've got the greater than sign, so just need to be aware of that. Negative 3, okay, now this is more practice with distributing negative numbers through a polynomial in brackets. Some people are struggling with this on the quizzes. So it's something that you just need to know for grade 10 and above. Negative 3 times x is negative 3x, and then negative 3 times a positive 1 is negative 3, and then nothing changes on the other side. Let's get this minus 3 taken care of, so we'll add 3 to both sides, and then we're left with 27 plus 3 is 30. Now we've got to divide by -3, and this is the first time we have to flip a sign, right? Because oh no, maybe it's the second time, never mind. But because, oh no, maybe it is the first time. Yeah, it is the first time. So because we're dividing by a negative number here, we need to flip the sign. So instead of greater than, it becomes less than, and I always write that sign first so I don't forget to do that. And then that cancels to x, and 30 divided by -3 is -10. Okay, we've got another inequality here, so let's keep that in mind. On this side, we've got -3w and 5w, and then on the other side, we've got a 3w. And then our constants are 19, 8, and -9. So let's just work on this side for a bit here. We've got a positive 5w and a negative 3w, so that's going to be a 2w. And, I'm just going to get rid of this 19 right away. Okay, so I've got 2w on one side greater than. And then 8 minus 9, so these two, 8 minus 9 is going to be -1, and -1 minus 19 is going to be -20. And I still got the negative 3w here, so negative 3w, and I said that this is -1 minus 19 is more negative, -20. Got to bring the 3w to the other side, so I got to add 3w to both sides. And I'm left with 5w is greater than -20. Divide by 5, so the sign doesn't need to change because we're dividing by a positive number. And that leaves us with w equals -4. Now, it didn't matter that there was a negative on this side. It's because we were dividing by a positive 5. So don't be thrown if there's a negative on the other side of the inequality. It's only if you're multiplying or dividing by a negative number. All right, another inequality. This time's greater than or equal to, and we've got questions that we've got to distribute a negative on both sides. So 3 times n is 3n. 3 times -2 is -6. -6 times n is -6n, and -6 times -2 is a positive 12. Now let's just keep simplifying. Let's add the 6 n's to both sides. So that's 9n, and then we got to add 6 to this side and add 6 to this side to cancel that out. So I got -n on 9n, sorry, positive 9n on one side, and then I've got that cancels out, and I've got 12 plus 6 is 18 on the other. We just need to divide by 9, which leaves us with n is greater than or equal to 2. There were no negative or divisions or multiplications, so we don't need to flip the sign. This one is also an inequality. And here's one that kind of traps people sometimes. When you've got minus and then something in brackets, a polynomial in brackets, remember that's like -1 times each of those numbers. So that you got to make sure you distribute that negative sign through the polynomial. And as we know, that really just changes the sign. It just flips the sign on the inside. So a 2 becomes a -2 and a -5g becomes a positive 5g. But we'll get to that in a second. Okay, so let's start at the front here. 2 times g is 2g, and then 2 times 3 is positive 6, plus our 8g, nothing changes there. Less than or equal to 18, nothing changes, and now this is where we got to distribute, right? So -1 times 2 is a -2, right? So -2, and then a -5g times a -1 is going to be a positive 5g. Now let's just keep work on getting our variables on the left side and our constants on the right side. So what have I got over here? I've got 2g plus 8g is 10g, plus 6 is greater than or equal to 18 minus 2 is 16, and then I'll just leave the 5g. Okay, let's bring the 5g to the other side, so I got to subtract. So I'm left with 5g over here, and then I got to subtract 6 from both sides, so that cancels, and I'm left with 5g is less than or equal to 10. And then divide by 5. What am I doing? Divide by 5, both sides, and that cancels, leaving us with g is less than or equal to 2. And once again, we divided by a positive number, so we don't need to flip the sign on that one. And I'm just going to check my answers with my answer key, and make sure I didn't make any silly errors, unless my answer key also has an error, which has happened before. 10, 20, 41.2, and 50. Okay, looks good. Move on to page 2, and there's a few more here. These 3 are all equations, so just got some more fractions to deal with. So we've got fractions, a fraction in front of our variable, which is, so essentially the fraction is a coefficient because it's multiplied by the variable. We've got fractions on both sides. Always try to kill the fractions first. So what we need to do is we need to find a common multiple between 3 and 4. So, let's try and figure out what that would be. It's not 3, and then 3 times 2 is 6. It's not that. It's not 9. 12 is the next one. So I just started at 3, went 3 times 1, 3 times 2, 3 times 3, 3 times 4, and I got 12. So what I need to do is I need to put a 12 at the top of both sides, and then I'm going to cancel top and bottom and see what I have left. So I have 12 on the top and 3 on the bottom, so cancels out, and I'm left with 4 up the top there, right? 12 divided by 3 is 4. The whole point was to get rid of the fractions. That's why we're doing this. And now 12 divided by 4 on the bottom, that's going to leave us with a 3 up top on this side. So what we've got now is 4. Don't forget to multiply it by whatever is on the top of the fraction, the numerator. So it's 4 times 2 is 8x. Right? Still the x there. And then 3 times 3 is 9. So we got to divide both sides by 8. And then we're left with the fraction. 8 equals, x equals 9 over 8. I think this might have been a quiz question, actually. And then we never leave it as an improper fraction. So that should be written as, how many times does 8 fit into 9? It fits in 1 time. And then what's left over? 1 over 8. 16, more fractions, same thing. We need to find the least common multiple for the denominator here. So we got to look at 2, 5, and 4. 2 times 2 is 4, works with the 4, doesn't work with the 5. 2 times 3 is 6, doesn't work. 8 doesn't work. 10 doesn't work. Doesn't work with the 4, right? So we got to go all the way up to 20 on this one. So I'm just going to write 20 at the top. Don't forget, you have to multiply all the constants by 20 as well. Okay, it's not just the fractions. You got to multiply every single term. So we'll do what we did before, right? We got 20 on top and 2 on the bottom, so now that equals 10 times the top. We got 20 on top of 5 on the bottom, so now that's going to equal 4 times the top. 20 times negative 3 is just going to be 20 times negative 3. 20 on the top, 4 on the bottom is going to be 5 times, and then 20 times 3 over here. So what do we have left? We've got 10 on the top times x is 10x. We've got 4 on the top times 2x, minus, negative sign there. So 4 times a negative 2x is negative 8x. Then we've got a negative 3 times 20, which is negative 60. And then on the other side of the equation, we've got a 5 times x, both positive, so that's going to be 5x. And then we've got 20 times positive 3, which is a positive 60. So now we've got rid of all the fractions, and we can just simplify. Let's bring our x's to this side. So I'm going to subtract 5x from both sides. And this is going to leave me with 5x minus 8x. I'm just kind of doing it one step at a time. That cancels. 60. Okay, now I can kind of do both of these at the same time. So we got 5x minus 8x's, so I'm going to be a negative 3x there. And then I've got to add 60 to both sides. Cancels there. So I got negative 3x equals 120. Now I did a divide by negative 3 to leave x alone. And then x is going to be, what is that, negative 40. So, I mean, fractions can be intimidating, but we've worked with them enough that hopefully by this point we're not too worried about them. Okay, well, good, because we got another one right here. We've got another equation because we got an equal sign. We've got a 3 in the denominator and a 4 in the denominator. Now this 3/4 needs to be multiplied by both the 20 and the negative x, but I always recommend you get rid of the fractions first, right? This is where some math teachers disagree. Some math teachers think you should multiply through this first. I always want to kill my fractions first. So I'm going to find a common multiple between 3 and 4, and that's going to be 12. We already had one of those earlier. So I'm going to multiply 12 by each of these. Now here's the thing you got to be aware of. Because this is already a multiplication statement, you do not have to multiply the 12 by everything in the brackets. That's going to come later after we simplify the fraction. So you need to understand the difference between looking at something like this, where it's 3/4 and then in brackets multiplied by 20 by x. You got to know the difference between that and something up here where these are all subtracted, right? There's no multiplication. That's why you had to multiply the 20 by every single term, because there was no multiplication. All we've got on this side is subtraction, and all we've got on the other side is addition. But when we have multiplication, we just multiply that by the coefficient really outside of the brackets. So just be aware of that. All right, so let's move here. 12 on top, 3 on the bottom, so that's going to cancel to 4 times. And then we've got a 4 on the bottom, 12 on the top. That's going to cancel, or that's going to simplify to 3 times. Don't touch anything in the brackets yet. And then we've got 25 times 12. There's no fraction there, so that's just straight 25 times 12. I think is 300. What are we left with? We got 4 times 2 and then times x. So 4 times 2x is 8x. Then we've got 3 times 3 is 9, and we didn't touch anything inside the brackets yet. And then we've got 25 times 12, which I believe is 300. Got that right. Sorry, I forgot the plus there. Okay, now before we do anything else, we gotta distribute this positive 9 through the brackets. So I'm going to leave the 8x, and then I've got 9 times 20 is 180, and then I've got 9 times a negative x, which is negative 9x, and then nothing changes on the other side. So we've got to bring this negative 180 to the other side, and then we can simplify 8x minus 9x. So 8 positives minus 9 negatives is going to leave us with a negative x, and then 300 minus 180 is going to leave us with a positive 120. And we don't want to leave a negative x, right? So we're just going to divide by negative 1, and then you can write x equals negative 120. If you don't want to show this step, and you just know that if you have a negative x equals something, that you can just flip both the signs, then that's fine too. So x should equal negative 120 on that one. Just want to check my math on that because I feel like I made a mistake. Nope. Might be okay. Maybe I should check that one. I got lots of room over here. Let's check it. Feel like I made a mistake on that one, so let's find out. We got 2/3 times a negative 120. Plus 3/4 times 20 minus a negative 120. Just be very careful with your signs. Equals 25 on the other side. Okay, now I don't need to kill these fractions because the numbers in the brackets will kind of do it for me because I don't have variables. So this one should be relatively easy. Okay, so when you're multiplying a fraction just by a whole number, remember it's just the top times that over the bottom. So it's 2 times negative 120, so that's negative 240 over 3. Plus, let's figure out what's in the bracket first because we've got bed math going on here. So we've got 20 minus a negative, so that just turns into a positive. So 20 plus 140 is 20 plus 120 is 140, and then we've just got 25 on the other side. Now let's simplify these as we move across. Negative 240 divided by 3, that divides out nicely to pen. Plus 420 divided by 4, well, I hope it's 105, so let's do a quick little math of the margin here. 420 divided by 4, 4 goes into 4 one time. 0, how many times does 4 go into 2? It doesn't go in any time, so I can bring down the other one. 0, how many times does 4 go into 20? 5, so 105. Does that equal 25? 80, sorry, negative 80 plus a positive 105 does indeed equal 25. That one checks out. Okay, so I thought it might be wrong, but with the verification, it checks out, and I feel very comfortable handing the exam in. Okay, it says do a check for the following equations, and here's the check. You're going to check 4x is equal to negative 4, and this one you're going to check for x equals 3. So that's just telling you what numbers to substitute in for on your checks. So let's solve the inequality, and let's see if they check out. Negative 2, we got more distribution here. So negative 2 times 3x is negative 6x, and then negative 2 times 5 is negative 10, and then we got a negative 3 plus x. Let's bring the x to the other side. Negative 6 minus 1 more is negative 7x, and then we got to add 10, and then so that cancels out. We got to add 10, that cancels out. And we got negative 3 plus 10 is going to be a positive 7. So now we are dividing by a negative 7, which means that we have to flip our sign over, and we're left with x on one side and negative 1 on the other. And our check is supposed to be for x equals negative 4. So let's sub it in. Remember, you got to sub it into the original because we already know that negative 4, so if x is negative 4, negative 4 is less than negative 1. That's true. So now we got to check if it's true in the original equation as well. So negative 2, and then 3 times x, so x is negative 4, plus 5. Run out space here, sorry. And is that indeed, question mark, greater than -3 plus x, which is -4? So let's just solve inside the brackets first. I'll keep the -2 out front. We've got 3 times -4 is -12, and -12 plus 5, -12 plus 5 is going to be a -7. And then over here, we've got -3 plus a minus. Well, plus a minus is really just minus, right? So -4. So we got -2 times -7 is going to be a positive 14. And is that indeed greater than -3 minus 4 is -7? Well, clearly 14 is greater than -7, so that one checks out. Remember, you got to check with the original sign too, right? Like at the end, our sign was less than over here, but the original equation has a greater than sign. So make sure you check with the original equation. Okay, this one, there's a negative in front of the brackets, and there's polynomial, so we know that that means multiplying by -1, or if you want to do it the simple way, just switch the signs, right? So instead of x plus 3, we're going to have -x and then -3, and then this one we can distribute. So that's -3 times 2x is going to be -6x. -3 times +2 is a -6, is less than 21 plus 2x. Okay, let's bring the x's over. So I'll just underline my x's to make it a little easier on myself. I got to subtract 2x from this side and from this side. So I've got -x minus 6x is -8x minus 2 more x's is -10x. So I took care of all my x's. And what have I still got left on this side? Then I'm just going to, my numbers, I've got a -3, then a less than, sorry, I got a -6 on that side too. Sorry. So I got the -3, I've also got a -6, then the less than, and then I've just got the 21 on the other side. So -10x minus 3 minus 6 is -9 is less than 21. -10x. Got to bring this to the other side by adding 9, so that cancels, and that is 21 plus 9 is 30. Now it should be nice even division. We are needing to divide by -10, which means we need to flip our sign. And we're left with x is greater than 30 divided by -10 is -3. So we're reasonably confident in that answer, but we need to verify it with x equals 3. Okay, so if we start with x equals 3, well, we know that on one side, and you typically don't even write this one, but just so you know what I'm comparing it to, if x is equal to 3 and I put the 3 in there, what I'm left with is that 3 is greater than -3. Well, that's very clearly true, right? That isn't much of a check, okay? The check comes when you plug it back into the original. That's the only way you can tell if it's been done properly. So as I verify this, we've got a negative, and then x is -3, and then that was +3. Well, that's going to be nice and easy. Then we've got -3 times 2 times x, so 2 times -3 plus 2. And then on the other side, we have is less than 21 plus 2, and then times x again. So x has got to be +3. Why am I multiplying by -3? Oh, silly Dunbar. I was looking at this, and I needed to be looking at this. So I just got, I guess, sub in a +3, not a -3. Anyway, so let's just rewrite it. Negative, and then x is 3 plus 3. And then -3 times 2 times x, which is +3. Oh, of course, now my pen starts causing problems. -3 times 2, and then the x is 3 plus 2 brackets, and then it's less than 21 plus 2 times 3. It's like 2b. Or not 2b, 2 times 3. All right, let's see if this works out. So we've got to do our brackets first. So 3 plus 3 is 6, right? That's pretty easy. So -6 minus 3, let's figure out what the brackets are. 2 times 3 is 6, plus 2 is 8. And then that should be less than, I should put a question mark here because that's what we're testing. 21 plus 2 times 3 is 6, so 21 plus 6 is 27. Let's just keep working our way down here. -6, then I got to go -3 times 8 is -24. It's less than 27. question mark. And negative 6 minus 24 more is negative 30. That is indeed, negative 30 is clearly less than 27. So that checks out. Write the inequality statement for each of the following. It says use C as a variable for 2 marks each. It's probably only worth 1 mark each on the exam because this is not particularly difficult. If you know that a circle that is not filled in means that negative 2 is not included to that, and the arrow is going to the right, so it is getting greater. So in this case, C must be greater than negative 2. Next one, we've got a 1, and the dot is filled in, which means it includes 1. These are all continuous. There's no discrete functions here. So this one is going to be C is greater than or equal to, because it could include 1. This one's got the circle again, so this one's just going to be C is greater than 1. This one has the dot, so it's going to be C is greater than or equal to negative 2. Now they were all going towards to the right on this one. On the exam, you can expect at least one of those will go to the left. Graph the following inequalities. So you've got to solve for the variable first, and then you've got to put it on a number line. So in this one's pretty simple here. We just got to divide by 2 on both sides, and that's going to leave us with y is less than or equal to 7. So you can set that up any way you want. There's 2, 4, 6, 8, and then negative 2, negative 4, negative 6, negative 8, and so on. And on the exam, because the lines are black, please make sure that you shade it in really well so that it's easy for me to see. It's tough if somebody's got a dot or a circle, and then I can't tell if it's the black line that they started with or if they drew one in there. So just make it a nice thick bold line. I'll use red on this one to indicate mine. So y is less than or equal to 7. So I got to find 7. It's right there. Because it includes 7 with the equal part, I'm going to make sure that that's a dot, and then I'm going to draw a line in red that needs to go, that needs to go out, because it's less than, it needs to go out the bag this way. Why isn't that red? Go. Okay, so that takes care of number 1. Next one, I'll just do it all in red, it'll be easier. Now I've got to do a little manipulating here, so I'm going to keep the y there. I'm going to subtract 5 from both sides, and what I'm left with is negative y is greater than 2 minus 5 is negative 3, but because I've got a negative here, I've got to divide by negative 1, which means I have to flip the sign, and it's just going to be y equals 3, right? Because I'm dividing both of those by negative 1. So they're both negatives divided by negatives, which makes it a positive, but I had to flip the sign, so that's very important. And, okay, so less than 3, I could probably do something very similar as last time. There's 0, there's 2, 4, 6, 8, and then your negative 2, negative 4, negative 6, negative 8, and so on. Let's draw a line. And it's y is less than 3, so I'm going to draw that line. Oops. Draw that line. 3 out this way, and then also don't forget this does not include 3, so that is going to be like that. It's a pretty good idea to write down what the number is too here. So, all right, we've got decimals, so you can feel free to work in decimals. Let's bring this 2.7x to the other side, so that's negative 2.7x. And 1.3 minus 2.7 is going to leave us with a negative 1.4x. And then let's bring this 2.5 to the other side. So I got to do minus 2.5 on both sides. That cancels, that cancels. Negative 2.4, and then going further, negative 2.5 is going to leave us with a negative 4.9. And then in order to get our x alone, we have to divide by negative 1.4 both sides. And because we're dividing by a negative, we've got to flip our sign. And what we're left with is x. I think that's 2.5. I'm just going to trust my answer key, and hopefully that is a positive 2.5. And we're going greater than or equal to this time. So let's put 0 here. And this will be, let's make this 1, 2, 3, 4, 5, 6, 1, 2, 3. So let's start at 2.5, and it includes 2.5, so that would be right here. And because it includes 2.5, I'm going to put a dot, then I'm going to draw my line. And my line is going to start there and go out that way. Make sure you have an arrow. My arrows weren't very big, so I'm just going to make them more obvious. But anyway, make sure that your line is obvious. You know, even if you have to do something like this, just make sure it's obvious to me. Okay, word problems, and this is where I mentioned it was important that you review those word practice problems I gave you, because the unit exam is going to include a couple of different types. All right, we're going to use our 5 steps. We've gone over this before. Find 3 consecutive integers whose sum is 12. So just take it step by step. Number 1, we've got to set what our variable is. So it's going to be let x, and then it's consecutive integers. So what are consecutive mean? Okay, back to back. Okay, so for instance, 2 and then 3 and then 4, they're all integers and they're in a row. And you assume they go positive, right? So 3 consecutive integers, 2, 3, 4 would be an example. That's not necessarily the answer here, but that's an example. So actually, I'll leave that there for a second. I'll show you why I'm doing my variables this way. Let x, okay, and then I'm going to put a comma, x plus 1, and then another comma, x plus 2 be my numbers. Why did I do x plus 1 and x plus 2? Well, if they're consecutive integers, if you add 1, you're going to get the next one. And then if you add another 1, you're going to get the third one, right? So 2 plus 1 is going to be 3, and then 2 plus 2 is going to be 4. So that's why I have the plus 1 and plus 2. So there's my let statement. Now you draw your equation, okay? And it says the sum, so that's addition, is 12. So the sum of these numbers, which is going to be x plus 1 plus x plus 2, that's the addition of all 3 of these, needs to be 12. So now we just solve it. X plus x plus x is 3x. 1 plus 2 is 3 equals 12. 3x, let's bring the 3 to the other side. And then divide by 3. We got left with x equals 3. So now we got to verify that. So that's, oh, sorry, this was step number 3 when we solved it. Step number 4 is we're going to verify that. And we can verify that just by plugging it back into the original sentence. 3 consecutive integers whose sum is 12. So if x is 3, our 3 integers are x, and then x plus 1, right? So x plus 1 is going to be 4, and then x plus 2 is going to be 5. You could have written it out like that, or if you wanted to take the original statement, it's really 3 is x plus 3 plus 1 would be the next one, plus 3 plus 2, right? That'd be x plus 1, x plus 2, and then we know that the sum of those is equal to 12. So it's really the same thing. This is just one more step, right? So this is 3 plus 4 plus 5, and then does that, question mark, equal 12? Hopefully it does. 3 plus 4 is 7, plus 5, I'm probably taking more steps than I need to here. Obviously 12 equals 12, so that checks. And then don't forget the final part, the 3 numbers are 3, 4, 5. Your sentence. All right, more. 3 consecutive even integers. This is the important word here, even, whose sum, so that's plus, is negative 60. Okay, now if we think about even numbers, let's just use an example over here. 3 consecutive even numbers would be something like 2, 4, and 6. So if we consider the x to be 2, then how do we get from 2 to 4? Well, we have to do x plus 2 to get to the 4, and then x plus 4 to get to the 6, right? If x is 2, 2 plus 2 is 4, and then 2 plus 4 is 6. So it's very similar to the first question, just instead of being consecutive integers, it's consecutive even integers. And this works for odd integers as well. Okay, so you don't need to change a thing for odd integers. So let's let x, then x plus 2, and x plus 4 be our numbers. Set our equations. The equation is pretty simple, right? They sum to negative 60. Okay, so that means x plus 2 plus x plus 4. You can put these in brackets if it makes it, separated it out easier for you, that's fine. We know that that equals negative 60. Now we're going to go to number 3, which is solve. So x plus x plus x is once again 3x, and then this time 2 plus 4 is 6. Okay, just adding all the like terms together. There's my x's, and there's my two numbers, right? Then we got to solve, right? So 3x, got to get rid of the 6. So we got to subtract 6 from both sides. 3x equals negative 66, right? Negative 60 minus 6. Divide by 3 to get the x alone. And we got x equals negative 22. So we hope that's the answer. So if x is negative 22, let's sub it back into the original. Let's see if it checks out. So here's our verification. 3 consecutive even integers whose sum. Okay, so our integers have to be x. So that's going to be negative 22 plus negative 22 plus 2 plus negative 22 plus 4. Okay, and does that equal question mark negative 60? Sort of ran out of room here, sorry. So negative 22 plus, what's in the brackets? Negative 22 plus 2 is going to be negative 20. So I've got plus negative 20. You might as well just write that as minus 20. Okay, so this was negative 20 here. And then negative 22 plus 4 is going to be negative 18, right? So negative 22 minus 20 minus 18, does that equal negative 60? Okay, that's negative 44 minus 18. That doesn't equal negative 60. I made a mistake somewhere. Oh, that doesn't equal negative 44. That equals negative 42. There we go. That's why we verify. Equals negative 60, question mark. Negative 42 minus 18 does indeed equal negative 60. So this one checks out. Don't forget the fifth step. Okay, fifth step. The numbers are negative 22, negative 20, and negative 18. All right, these are 3 consecutive even integers, but because they're negative, the numbers are getting smaller as it gets closer to the 0. Length of a rectangle is 5 centimeters more than the width. Perimeter of the triangle. Okay, don't forget perimeter is fence around, right? Perimeter of the rectangle is 34. Okay, so these ones, the length or the width, right? And it usually gives you the width and then tells you something about the length, right? So let's say let W equal width, and then length, probably write it the other way around. What do they tell us about the length? The length of a rectangle is 5 more, well, more is plus, than the width. Okay, so that's actually super easy. The length is 5 centimeters more than the width. So if width is W, okay, that means that the length has to be W plus the 5 centimeters, right? Equals the length. So why? It just tells us that. It says the length is 5 centimeters more plus than the width. So number 2, what do we know about perimeter? We need 2 sides. Okay, so let's look at a rectangle. Okay, so we're going to have the width is W, and then the length is going to be W plus 5. So if we're building a fence around this, remember it's not area, we need 2 W's and we need 2W plus 5. So let's just make that very simple by writing 2 times W plus 2 times W plus 5. That needs to equal 34. It told us so. So let's solve this equation then. 2W plus, remember, distribute, right? So that's 2 times W is 2W, and then 2 times 5 is 10 equals 34. We've got 4 W's here. We've got to subtract the 10 from both sides. 4W equals 24, and then divide by 4. W equals 6 centimeters. Don't forget the units. Okay, do not want to have to subtract marks for units, but it is happening quite often. Okay, let's go to number 4. Let's verify. So we got to sub it into the original equation, which is basically the chart up there, and see if it works out. So let us check the original equation, which is 2 times W, which we think is 6, plus 2 times W plus 5, so 6 plus 5. Does that equal, question mark, 34 centimeters? Because it needs to. 2 times 6 is 12, plus 2 times 6 plus 5 is 11. Does that equal 34 centimeters? We've got 12 plus 2 times 11 is 22. Does that equal 34 centimeters? And 12 plus 22 is indeed 34. Does equal 34. Check. So our final statement is the length is, W plus 5. So that's going to be 6 plus 5, 11. 11 what? 11 centimeters. And the width is 6 centimeters. And you could have written that the other way around. You could have said the width is 6 centimeters and the length is 11. But you just got to remember the width is W, so 6, and then the length is W plus 5, so 6 plus 5 is 11. So make sure you answer the question that it gives you, right? When you write your final sentence, make sure it matches up with what they're asking you to find out. All right, last two questions. These are just sort of general number ones. Two numbers have a sum of 30. Well, we know sum is plus. The second number is twice as large, so that's multiplication, right, as the first. So let's figure out what our numbers are. Let x be the first number, say. And then, how do we figure out the second number? Well, if two numbers add to 30, that means we can do it backwards, and then 30 minus that number has to equal the other one, right? So let 30 minus x be, and I'll just put num 2. Set up our equation. Two numbers have a sum of 30. Okay, we already kind of took care of that. The second number is twice as large as the first. Well, which one's the second number? Okay, the 30 minus x is the second number. All right. So the second number is twice as large as the first. So the first number plus the second number, okay. Oh, I'm sorry. The second number is 2 times. Oh, I don't even need to do this. Two numbers have a sum of 30. The second number is twice as large as the first. Oh, okay. You know what? We could have done it this way, but there's actually even an easier way to do it. Okay. Even easier. Two numbers have a sum of 30. The second number is twice as large as the first. So if the first number is x, then the second number can just be 2x, right? By the way, if we'd have done it the other way, it would work too. But this one I think is easier. If the second number is twice as large, oh dear, what happened? If the second number is twice as large as the first one, oops, there we go. Get back in space there. Sorry, if the second number is twice as large as the first one, well, if the first one's x, twice as big as x would be 2x. So I think it's just a simpler way of writing it. All right, so let's set our equation. Now let's use this 30 part, okay? So two numbers have a sum of 30, which means that x plus 2x, so the first number plus the second number, must equal 30. So this is really simple now. X plus 2x is just going to be 3x equals 30, and then we need to divide by 3, and we're left with x equals 10. So we're thinking 10 is the number, but we need to plug it into the original, right? So if this is indeed true, then x is 10, plus 2 times 10 needs to equal 30. And we can see it does, right? 2 times 10 is 20. Does that equal 30? 30 equals 30. It checks. So that was the fourth step, which was the verification. And the fifth step is the two numbers are 10 and 20. I guess I need a comma there. 10 and 20. And 20 is indeed twice as big as 10. Okay, find 3 consecutive integers. So the word there, the word's important there, it's 3 consecutive integers. So that would be like a 2, 3, 4 kind of thing. So that the sum of the first 2 is 33 more than 2/3 of the third. Oh my goodness, so many words here. Okay, well, let's just do it one step at a time. If they're consecutive integers, we know something, okay? So let x, and then if they're consecutive integers, they got to be x, x plus 1, and x plus 2. Be the numbers. So we don't know what those are yet, but we know that they got to be consecutive, so it's going to have to be x, x plus 1, and x plus 2. Okay, now this might be a little bit tougher here. We got to find an equation. So let's just look at it word by word. The sum of the first 2. Okay, well, the sum of the first two, that's x and x plus 1, right? So let's start with that. X plus 1, that would be the sum of the first two. You don't need the brackets, but I'm just putting them in there to remind myself that x is the first number, x plus 1 is the second number. So we took care of up to there. You just read it a couple words at a time, and you won't get confused. Because you try to read and figure that out all at once, it's just, there's a lot of stuff going on. Okay, is 33 more than? Okay, so this is 33 more than another one. So I can do this a couple ways. If the sum of these two is 33 more than the other side of the equation, what I can do here is I can just subtract 33, okay, from this side. So the sum of the first two, move that silly thing again, lock those down, really lock those down. Okay, sorry, where was I? Okay, so if the sum of the first two, so that would be this part, is 33 more, so if I take that sum and I subtract that 32 or 33, it should be equal to whatever's on the other side of the equation, right? So I could have added 33 to this side if I wanted to, or you can subtract it from this side. It doesn't matter. It does the same thing, right? Either you add 33 to one side or you subtract 33 from the other. So it doesn't matter which side you wanted to put that on. I just chose to put it over here. So I took care of up to the 33 more part. Okay, now 2/3 of the third. Well, 2/3 is a fraction. And then we know the third number is x plus 2. So if you write it out just sort of one little chunk at a time, it becomes a lot easier. Your equation just kind of builds itself. So don't try to solve it all at once or write it all at once. Just do it a couple words at a time. Okay, now let's solve this thing. X plus 1, well, there's two x's there. Okay, and then we've got plus 1 minus 33. Remember, there was no multiplication here. It's addition. That's why I just dropped the brackets. On this side, however, I've got multiplication, and I should get rid of that fraction. Okay, but I'm just going to simplify a bit more over here. You could have done it right away if you wanted, and it probably wouldn't have been a bad idea. But I've got a couple numbers hanging around here, a couple like terms that I can combine. So 1 minus 33 is going to be negative 32. Equals 2/3 times x plus 2. Okay, now let's kill this fraction. I could have done it earlier, but let's kill it now. If I'm going to kill this fraction, I have to multiply everything by what's on the bottom, which is 3. So don't forget, every term separated by a plus or a minus needs to be multiplied by 3. Now, because this is multiplied by this, right? It's touching, the 2/3 is touching the brackets. You only do it to the top number. You don't do it to the x, and you don't do it to the 2. So the 3 up here cancels with the 3 down there. That was the whole point. 3 times 2x is 6x. 3 times negative 32 is going to be negative, 96. And then on the other side, we've just got the 2 left, right? Because we nixed the 3's. And then we've got the x plus 2 in the brackets. 6x minus 96 equals, well, we got to distribute, right? So that's 2 times x is 2x. And then 2 times 2 is 4. Okay, now we're into very simple territory here. Just subtract 2x, subtract 2x, we're left with 4x. And then we've got to bring the 96 to the other side, so we've got to add 96 to both sides. That nixes this out, and I'm left with 4x equals 4 plus 96 is 100. That's pretty simple math. Divide by 4, and I'm left with x equals 25. So I'm hoping the answer is 25, but we're not going to know until we sub it in. And the check on this one's, it's not the easiest check in the world because we've got some fractions and stuff in there. So let's look at the original equation that we had. We had x right here in number 2. Okay, so we had x, which we hope is 25. So 25 plus x, okay, that's 25 again, plus 1 minus 33 on the one side. Does that equal, question mark, 2/3 times the 25, which is x, plus 2. I could kill that fraction right away, but I think the numbers are going to kind of do it for me. So I'm just going to carry on here. 25 plus 25 is 50, plus 1 is 51, minus 33 equals question mark. Okay, let's see what happens. And I know I normally say kill these fractions right away, but I'm just going to see what happens here if I multiply 2/3 times 25 plus is 27. Because I'm thinking I don't have to do anything. I'm thinking this number right here is going to kill this fraction, and it will. Okay, I'm recognizing, what is my thought process for that? What I'm thinking is I know that I knew that this was going to equal 27, right? And I know that 27 and 3 divide nicely. So I'm going to have a 27 up top over here, and I'm going to have a 3 on the bottom, so I know it's going to cancel out nicely. That's why I'm not going to bother killing it by multiplying everything by 3. All right, 51 minus 33 should be positive 18. Is that equal to... Okay, now here's where it happens, right? You can multiply 27 by 2 and then simplify. But remember, 27 is just 27 over 1, right? So as long as you're simplifying a top and a bottom, you're good to go. So I'm going to cancel out the 3 because I'm going to divide both of these by 3, right? So 3 divided by 3 just leaves me with 1. And 27 divided by 3 leaves me with 9. So now I'm left with 2 over 1 times 9 over 1, which is just 2 times 9. So what's 2 times 9? 18. That checks out. And then for our fifth, so we did answer the question, and I think it was 3 consecutive integers. Okay, so your final sentence is the 3 integers are 25, 26, and 27. They weren't odd or even or consecutive integers. Good. So the 3 integers are 25, 26, 27, and that we proved that it checked out. And that concludes our practice exam. The exam questions are very similar to those, but there are also some multiple choice questions as well. It's a longer exam than the ones we've had before, so just make sure you're very comfortable doing this math and doing it relatively quickly and relatively accurately. There are, I believe, fewer word problems on the actual exam. If I remember correctly, I give you 4, but I only ask you to do 2. So doing word problems tends to take a bit more time. So we did 4 here, or 5, and you're only going to have to do 2 for the exam. As always, get on your studying early, and if you have any questions, feel free to email us. Good luck!